Very good afternoon to one and all who have joined us for today's session of the Faculty Development Program. I am Aishwarya Radhi, Assistant Professor at Tyagaraja College of Engineering, Madurai, Tamil Nadu. And it's my privilege to serve as your host for this enlightening series of talks in AMIEE. The AIMR Innovative Entrepreneurs and Engineers Association, AMIEE, is the leading professional organization committed to advancing AI, machine learning, innovation, entrepreneurship, and engineering across, with a mission to foster the growth and development of professionals while creating dynamic community for networking, knowledge sharing, and collaboration in these fields. It gives me a great pleasure to welcome our distinguished speakers for today's session, Dr. G. Suresh Babu sir, Dr. P. Narahari Sastry sir, and Dr. Anubhav Kumar Pandey sir, who will be sharing their expertise with us this afternoon. Let me begin by introducing our first speaker. We are honored to have you with us, Dr. G. Suresh Babu, a seasoned academician and researcher with over 3 decades of experience in teaching and mentoring. He is currently serving as a professor in the Department of EEE at CBIT, Hyderabad, where he has been inspiring minds for over 26 years. Dr. Suresh Babu holds an ME in Industrial Drives and Control from Osmania University and a PhD from JNTU Hyderabad. He has guided 30 plus ME projects and 3 PhD scholars and is a recipient of prestigious awards, including the Dr. APJ Abdul Kalam Best Teacher Award. His interests are diverse, ranging from electrical drives, renewable energy, energy management, to the profound wisdom of Vedic mathematics and Indian knowledge systems. He also serves as a master trainer under the UGC AICTE IKS initiative, promoting our Bharatiya Janana Parampara. Welcome, sir. We are honored to have you with us today, sir.
Thank you very much, Aishwarya. Shall I start sharing, please?
Yes, sir.
Okay. Is it visible, please?
It's loading, sir.
Aishwarya, is my
Sir,
slide visible?
yeah, it's visible now. It's
Shall I
visible.
start?
Yeah, sure, sir.
Okay. Thank you very much, Aishwarya, for your nice words. My dear participants, Sri Guru Pyo Namaha. The topic given to me is condition monitoring and fault diagnosis. Okay. 1 minute. Next. Not moving. AIML in electrical engineering. The repertoire of somehow full function 5 is not working now. Yes. Is it okay now?
Yes, sir.
The repertoire of my lecture goes like this. I request Aishwarya to frequently respond to me, please, because whether it is visible or audible or not, I request Aishwarya on behalf of organizers to respond frequently, please. Aishwarya. Okay. Repertoire of my sequence goes like this. Invocation, session objectives, expected outcomes, exposition, key takeaways, introspection, peroration, and acknowledgement. It is my tradition to start any such deed by saluting my parents. So now also, Mataram Subbalakshmim Tam Prema Rupam Namamyaham Pitaram Ramachandran Cha Kotlur Yanvayasanmani. Session objectives. Why this session? Actually, as Aishwarya said, the total session is trifurcated. So myself, Narahar Shastri, and Anubhav Kumar, we are sharing the dais. So myself being the first one, I am talking about the basics of that one. So session objectives of my slot are like this: to introduce participants to the fundamental concepts and importance of condition monitoring in electrical machines and systems. So that is, let them understand why vigilance is the first dharma of maintenance. My dear participants, remember, vigilance is our dharma. So the first dharma, covered dharma rakshati rakshitaha. If you really vigilant about the vigilance, automatically it will protect the total system. That is the meaning. The second objective of this session is to provide an overview of fault diagnosis techniques and their integration with AIML algorithms for predictive maintenance and enhanced reliability. The word fault diagnosis is like a misnomer. Diagnosis is not fault. We are diagnosing to identify the fault. So be careful about the word. Fault diagnosis is no. Diagnosis is not fault. We are diagnosing to identify the fault. Okay. Next. What does it mean? Second objective means may they appreciate, that is participants, how intelligence transforms maintenance from reactive to proactive. That is second objective of the session. Next, coming to expected outcomes. Phalaswarupaha. First expectation is participants will be able to define and differentiate between condition monitoring and fault diagnosis with suitable daily life examples and technical examples too. That is first expected outcome. Second one is participants will gain superficial yet practical awareness of how artificial intelligence and machine learning techniques are applied in fault detection and predictive maintenance within power systems. I'm not going to talk much about predictive maintenance as my predecessor will take care of that one. Just I give only power systems also, and Kumar will discuss more. Just I give very basics of that one. Coming to prologue. So what is condition monitoring means? Keeping an eye in all the systems. So this is best understood. Condition monitoring. You have to go on monitor without disturbing the system operation. How vigilant we are on the machine. So condition monitoring and fault diagnosis, the vigilant eye of electrical engineering. There is one saying in Sanskrit, Yada sutram vichidyate tada vyatha jata bhavati. Whenever the thread breaks, suffering starts, arises. Yes, you should always anticipate in advance and save, protect the equipment and system too. What is condition monitoring? A proactive technique to assess health and performance of equipment during normal operation without interrupting it. It detects incipient faults before they escalate to breakdowns. That is condition monitoring. Why it is critical today? So it is so buzzword, it has become an industrial scenario. Why? Because it downtime costs are enormous, both economically and in terms of grid reliability and human safety. Condition monitoring is integral to predictive maintenance, enabled, enabling planned shutdowns and optimized maintenance schedules. Still, if it's not clear, let us see what exactly CM means. CM means the continuous observation of equipment health, continuous observation of equipment health to detect any change indicative of developing fault without interrupting operations. That is the best definition of condition monitoring. So what are the types of condition monitoring techniques are available? One by one we'll see it. Technique, what is the parameter monitored? An example application we'll see. First one, vibration analysis. The parameter being monitored there is bearing defects, imbalance of the wheel, etc. Example, in motors and generators, we apply this vibration analysis. Second one, thermography. In thermography, hot spots, overheating is identified, monitored. Example is transformers, switchgear equipment, etc. Even alternators also, machines also, you will find using a remote thermometer and will be able to identify hot spots. Next, third one, oil analysis. It will be used to monitor contaminants and wear particles in oil. The best example point is transformer and gearboxes. Next, continuation to this one, ultrasound technique, that is to find out leak detection, arcing, etc. It is found in compressed air systems, insulation faults. Next one, partial discharge measurement, that is insulation degradation in case of transformers and other HV equipment. Last but not least, electrical signature analysis. Electrical signature analysis, that is things that technique is being used, and it is found in induction motors, It is found in induction motors. Am I audible to you, please? Aishwarya?
Yes, sir, you're audible.
Thank you very much. Now, assessment of how frequently even a healthy person after crossing 40 years of age goes for regular checkup once in 6 months or once in a year without interrupting any day-to-day activities. That's called condition monitoring. In our health master health checkup, so many offerings has come from different organizations. We know it. So that is called condition monitoring. Okay. What exactly, why is condition monitoring is important? If you don't monitor, what will happen? It prevents unbalanced downtime. First one is it prevents unplanned downtime. All of a sudden, a person collapses. If particularly he has not taken care of his BP, sugar, and other cardiac maintenance, all of a sudden he may collapse. Similarly, the machine also, if it is not properly monitored the condition, one day, several days will occur to the machine. So the condition monitoring will prevent unplanned downtime, first one. Second one, it reduces maintenance costs because there is no need. Once you are aware that what is your BP level, sugar level, and other organs are at what level, you need not to spend much on medicines for maintenance costs. Similarly, for machines also, if you are able to monitor the condition of the equipment or machinery in advance, maintenance cost will be reduced. That is second advantage. Third one is it enhances safety, yes, and reliability. So once a person goes regular health checkups and is intact with health, he is safe and reliable, no doubt. Same thing applicable to machines also. Next, so this is called equipment failure cost pyramid. Repair cost reduces, replacement part reduces, equipment damage reduces, loss reduction reduces production. So all these things together, which will lead you to safe and reliable operation of equipment for a longevity. That is about failure cost pyramid gives us. Next, second one, vibration analysis. It's another technique of condition monitoring. Vibration analysis. What is vibration analysis? It measures mechanical vibrations to detect anomalies. To detect anomalies. For example, daily life example, if you take car steering vibration. If it is not proper, we will go. If you take to the workshop, the technician says that wheel must be balanced properly, sir. So please leave your car here for wheel balancing. So like that, that is daily life example for vibration analysis. Technical example, motor being analysis using accelerometers. They will test with the accelerometers. That is vibration analysis. If you see the graph, FFT, fast Fourier transform technique, spectrum showing varying fault frequencies for different frequencies, different amplitude you will be able to find at different times. This is only an example, it's not a case study. Next, second condition monitoring technique is thermography. What is thermography? It detects hot spots via infrared imaging. I told you, camera will be there, infrared remote thermometer, or we call pyrometer in industry to measure high temperatures. So it will be able to measure infrared imaging hotspots where it is. What is hotspot means? Where more heat is focused compared to the uniform distribution of heat. Daily life example, if you want to give fever gun temperature scanning. So nowadays, if you go to a doctor, the days has gone touching and keeping with the thermometer inside the mouth and all. Just with the fever gun, you'll be able to know what the temperature is there, how much, because it is probably this area, it will be more hot spots you find rather than the body. Though that's why they'll be able to keep the fever gun here and identify what is the temperature. Based on that, they will diagnose. Technically, switchgear thermography revealing loose connection hotspots somewhere. So this is a image you can understand 20 degrees centigrade to 80 degrees centigrade. So you find here in this 72.3 degrees centigrade is hotspot for the machine identified by the system or the instrument. That is called hotspot, which is checks oil for degradation, contaminations. Sometimes oil will be contaminated due to some humidity or etc. etc. So that we have to frequently check. So daily life example for this oil analysis is checking dark engine oil for replacement. And technical example is transformer oil DCA detecting acetylene for arcing faults. So this is the graph which you find concentration and thermal faults and electrical faults for different gases H2, CH4, C2H4, C2H2. Type of faults you'll be able to know where exactly thermal fault up to what level and electrical fault what level due to what concentration. This is only, as I told you, to give an idea about analysis, not any case study. Next, ultrasound analysis. What is ultrasound analysis means? It uses high frequency sound for leak or able to hear human being for leak or discharge detection. Daily life example is hissing sound in detecting gas leak. Practically in our domestic, if you find gas pipe running right from outside to inside kitchen. So if you find any leakage, find some hissing noise. That is sound analysis. But here in industry, ultrasound analysis means compressed air leak detection using ultrasonic detectors will be done. This is also another type of condition monitoring. You can see the example how it looks like. He is monitoring, just keeping that sensor on the surface and tracing its position through the display. That is called how this is ultrasound analysis being done as one of the condition monitoring technique. Next, partial discharge measurement. What is partial discharge measurement? It detects micro electrical discharges indicating insulation degradation. So, simple example: if we are weak, our enemy will try to get. So we should see that we should not become weak. That's the best. So insulation should not degrade. If insulation degrades, electrical discharge starts. Daily life example, spark from old socket, which indicates insulation failure. Technical example, high voltage cable partial discharge testing for insulation life assessment. Especially in transformer oil, we do this partial discharge test. See, this is a partial discharge detection waveform, amplitude versus time. It's not any case study, please. Next, electrical signature analysis. What is electrical signature analysis? Monitors current and voltage signals for abnormalities. This electrical signature analysis is very, very important. It monitors what is the voltage, what is the set voltage, set current. So if any abnormality occurs in the system, so those two values will vary. That will give indication that yes, there is very much badly need of electrical signature analysis should be undergone. Daily example is hearing distorted speaker sound indicates damage. So hearing without hearing impaired, how a dumb person will be able to know. Hearing distorted speaker sound indicates damage. That is daily life example for electrical signature analysis. Just only manual example. Coming technical example, MCSA for detecting rotor bar faults, very, very important, especially eccentricity, rotor eccentricity, air gap eccentricity is found out by electrical signature analysis. Rotor bar faults in induction motors. So this is the current spectrum of broken bar side bands. How from 200 to 400 amplitude and is varying. 1 second, please. Next. Fault diagnosis. The what is second part of my topic is CM and FD, condition monitoring and fault diagnosis. So I told you the name very interesting. Diagnosis is not fault. We are diagnosing to identify the fault. Fault diagnosis. Be careful about the word meaning. So what is the process being taken? For example, in daily life, doctors diagnostic flow or fever. So what is the questions he asks? From which parameters he will be able to diagnose that we are suffering from fever. So it is a regular process, everybody knows it. That's called diagnosis applied by the doctor to identify the fever, which is found for a human being. Technically, fault location. There are three stages to identify or to overcome them to carry out the fault diagnosis process: detecting, isolating, identifying. Remember, these three stage formula is most important for any fault diagnosis. First, you should be able to know whether fault occurred or not. Yes, occurred. Where it has occurred? What is the fault? If these things, if you put inquiry, automatically you will be able to diagnose the fault perfectly. Then taking care, or to call in case of a regular diagnosis called medication. In our industrial, this fault diagnosis terminology, we call maintenance. Predictive maintenance can go for it. Predictive maintenance or immediate maintenance. That is it follows the process. Let's see. So fault diagnosis process takes place in three stages. I said detection. Is there any fault? First. Next, isolation. Where is it? Immediately you isolate from the healthy circuit. Identification. What is the fault? Whether it is a line to line fault, line to ground fault, or a insulation to insulation fault, short circuit fault, open circuit fault. So identify automatically, accordingly, the compensation, rather maintenance will be done accordingly. Once the properly diagnosed, medication is very easy. All of you know it. In medical terminology for human health also, diagnosis plays a vital role by doctor. Once properly diagnosed, and medication is very simple, very simple. So next, let's see how the flow chart looks like. 1 minute, please. 1 minute. Sorry. Path for fault analysis. Fault detected, yes or no? Yes. Detection. Has the system sensed in an abnormal condition? Yes. Then isolation. That is where the fault localized to component circuit alone. Next, identification. What exactly is the fault type? I told you, know, there are number of types: open circuit fault, short circuit fault, line to line fault, line to ground fault, single line to ground fault, double line to ground fault. All these faults, once the properly identified, take corrective action. That's how. Next, corrective action only. So artificial intelligence and machine learning in condition monitoring and fault diagnosis. What is it? It automates detection and classification using data-driven models. First point. In daily life, how can you correlate? Smartwatch, ECG detecting all other cardiac or sometimes pulse rate, everything it is nowadays. Smartwatch, all of you know. That is best example. in AML, artificial intelligence in a health condition in our day-to-day life. Coming technical life, CNN, convolution neural network models are there. They classify the motor very fast with more than 95% accuracy. CNN, that is convolution neural network models. Next. So it is carried out in 3 stages: data acquisition, feature extraction, and model prediction. Data acquisition, feature extraction, and model prediction. That is carried out in 3 phases. Next, AML technical example. Suppose if we take case predictive maintenance for motors. Predictive maintenance for motors. Vibration plus temperature data fed to ANN, neural networks, which predicts RUL, that is remaining useful life. Remaining useful life. That is residual life assessment. Separate software is available. It is designed by PHL R&D. RLA, that is residual life assessment of any machine. So it predicts impact on this one. Impact on this one is maintenance planned before catastrophe failure occurs. That is called predictive maintenance. Prevention is better than cure. We know it. So that is AML technical example. Same can, if you see graphically represented, remaining useful life versus time. So actual remaining useful life and predicted life. How, and if you can closely observe, this is remaining useful life. As the time progresses, how it is uh, falling down, and if it is not properly taken, failure occurs at one point of time. Of time exceeds, it failure will occur, breakdown will occur in the machine. Next, what are emerging trends in this area? Majorly, I will tell 3 emerging trends. That is one digital twin, we call digital twin. The daily analysis of this digital twin is Google Maps live traffic, which we notice in Google Maps. Technical example is virtual substation replica. Virtual substation replica is best example for digital twin. And Edge AI trend. There is voice command processor in phone, which we find. In coming to technically, condition monitoring, IoT, Internet of Things sensor level is called technical example. And last but not least, sensor fusion, that is sensing danger via multiple sensors. Even multiple sensors connected for a system, you'll be able to know by taking the inputs from all the sensors, you'll be able to know what type of fault going to occur. So it's nothing but multiple sensors. In technically combining vibration analysis, thermal analysis, acoustic analysis, all together identifying at for a single system is another trend setting nowadays. Sensor fusion we call. This is smart grid with a digital twin is this block diagram. Next, what are the research directions in this context? Hybrid machine language models, machine learning models for multi-fault diagnosis. That is one of the best research direction. For multi-fault diagnosis, hybrid machine learning models are being arrived. Transfer learning for generalizing fault models. Transfer learning is another research domain. Acoustic emission based condition monitoring for high voltage equipment. Last but not least, blockchain integration for secure condition monitoring data management. Condition monitoring data management. So if you see research directions in a tree form, hybrid ML models for multi-fault diagnosis, acoustic emission-based condition monitoring for high voltage equipment, there are branches. Transfer learning for generalizing fault models, and blockchain integration for secure condition monitoring data management. Like this, it is made in 4 different branches, the tree being condition monitoring. And these are the exception directions condition monitoring. So this is a small topic because I told you the very big topic is trifurcated under 3 different people has been given small topic. I have finished my thing. Let me give highlight, conclude. Let us key takeaways, whatever I have said so far. may we engineers uphold the dharma maintenance, ensuring every transformer, motor, and live wires have its full life in service of society. That is dharma. Next, a very interesting quotation. An engineer who masters condition monitoring, he guards the temple of reliability. An engineer who masters fault diagnosis becomes the priest who restores its sanctity when disturbed. So you see, the person who masters condition monitoring, he guards, safeguards the temple of reliability. The person who masters about fault diagnosing the fault identification, he becomes the priest who restores its sanctity when it is being disturbed. Next, imagine your heart skipping a beat. Loved up, loved up, loved up. Would you want to your smartwatch to alert you instantly? Yes. Similarly, your transformer, motor, or switchgear deserves that constant vigilant friend that is nothing but condition monitoring integrated with AI fault diagnosis. Okay, my dear participants, this is the highlights. Before finishing my talk, let us introspect ourselves how much we have understood. I hope I don't want to test you, but it is left to each individual how much we are able to answer these questions. Be vigilant. First question: which of the following techniques is commonly used for detecting bearing defects in induction motors? Anybody can answer. Which of the following techniques is commonly used for detecting bearing defects in induction motors? Thermography, vibration analysis, oil analysis, partial measurement. Anybody to answer, please? Nothing will happen if you answer.
Vibration analysis.
Huh?
Vibration analysis.
Very good. Yes, it is vibration analysis. Next, second question. It's only to know how much we have understood, that's all. We are not going to grade anything at all. Predictive maintenance aims. Predictive maintenance aims to repair equipment only after failure, replace components periodically, or predict failures and perform maintenance just before they occur, or eliminate maintenance completely. Which one is correct answer?
C.
C. Very good. Excellent. Navamita Banerjee. Very good. Third question. Which AI model is best suited for time series forecasting in predictive maintenance? Which AI model is best suited for time series forecasting in predictive maintenance? CNN is convolution neural networks, LSTM is long short term memory, third one decision tree, fourth one is K-means. Which one? Time series.
LSTM. LSTM.
Exactly. Exactly. Very good. LSTM. Because time series. Next. Partial discharge measurement is primarily used for monitoring. Partial discharge measurement is primarily used for discharge monitoring. A. Mechanical misalignment. B. Electrical insulation degradation. C. Temperature rise. D. Oil contamination. Answer. Partial discharge.
B. B.
Very good. Banerjee, very good. Very good. Next. Fifth one. In AI-based fault detection of power systems, convolution neural networks, that is CNN, are used because they detect time dependencies in sequential data. They classify high dimensional spatial patterns effectively. They perform clustering of non-labeled data. They optimize PID controller parameters directly. Which one is correct answer? Anybody to answer? Banerjee?
Someone has already given the answer as B. I think,
Very good.
yeah, in the chat box.
I have not seen chat box. Okay, thank you. Thank you very much, Banerjee, for your cooperation. Okay, conclusion and the call to action. May these objectives, whatever I said, outcomes expected and questions become tools to chisel clarity in the minds of learners. Knowledge without testing is like gold without fire, unproven and unrefined. So it must be tested. Knowledge is there means whether it's a natural knowledge or artificial knowledge, it must be tested. Then only it will be proven. Otherwise, gold without fire. And I hope I reach you with fulfilling the objective of set at beginning. And I acknowledge all these people, to all my teachers, students, to my motherland, to my mother tongue, to the authors of all the books I read, CBIT authorities, and you who has patiently listened to me. Last but not least, I want to listen from you for any questions, ready to answer. Because time given to me is 3:40, I have made like that. Anybody, any question, please? Any questions are there in chat box, Aishwarya? Can you kindly help me out? I'm unable to see the chat box now. If anybody has posted any question, welcome. I'm ready to answer. Or any
No, sir.
comment, any
No question.
feedback. Okay. Namaste. Any questions are there? I conclude this one. Oh, Purnamada, Purnamida, Purnamudachyate, Purnasya Purnamadaya, Purnamevavasishyate. Shanti, 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 Shanti. जय हिंद वंदे भारत मातरम धन्यवादः पुनर्मिलामः I may be given permission to stop. Any questions? Ready to answer anytime. Yes, please. Over to Aishwarya.
Thank you, sir. Thank you so much. That was a wonderful speech. It's my privilege to welcome our next distinguished speaker, Dr. P. Naramari Sastry, Professor of ECE at CBIT, Hyderabad. With over 9 years of industry and 20 years of academic experience, Dr. Sastry is a passionate teacher, researcher, and innovator. He holds a PhD from JNTU Hyderabad, along with degrees in microwave engineering, marketing management, and an MBA in operations. He has guided multiple PhD scholars, filed and successfully granted a patent on palm leaf character recognition, and completed an AICTE funded research project on the same. With over 40 publications, including 8 in SCI journals and IEEE communications, he continues to blend traditional wisdom with modern technology in his research. It's an honor to have you here, sir. Welcome to the session.
Yes. Good afternoon, everybody. Am I audible to everybody?
Yes, sir.
Yes. Let me share the screen because the time is very short, 40 minutes. So let me share the screen. With all my industrial experience, I am presenting this session of more than 10 years, a decade. In the initial stages, I used to I used to work on predictive maintenance machines in the initial stages. Then in the year 2003, I have established an industry also in this area called MCM Instruments India Limited, India Private Limited. And I give my technical advice to the industry, even though I'm in academics. So with this background, am I audible and is my screen visible? Can anybody tell me? Am I audible and also the screen is visible, right?
Yes, sir. It's visible.
Yes. So the predictive maintenance of different machines is the topic what I have taken up for today. And I have worked in a company called Predictive Technologies India Private Limited. Even today, the company is there. 25 years back, I was the first person to get appointed into that company. And I was a machine analyst worked as a machine analyst in the initial stage, and these predict instruments were purchased, and we had a collaboration with Predict Technologies, Cleveland, USA, and still today the company flourishes and gives training to different people in Hyderabad. So from the industry, I came to the academics after a decade, and our main clients were like IOCL, IPCL, wherever there is a rotating equipment, like L&T cement plant. Awarpur was a very big client for us. Rajeshri Cement Works, L&T Tadipatri, these were the clients. So real time they use these things, and I was the main machine analyst there. So here, let me tell you what is my agenda. The examples of machine failure, what are the different types of maintenance systems, why preventive maintenance is so important, how the predictive maintenance came into the picture, and predictive maintenance, I remember in the year 1995, that is about 30 years back, it had come. That time we had only, we were using AI, but that special term of AI has come up nowadays, and we were using the same techniques. But nowadays we use the cloud computing and quantum computing and cloud computing instead of the servers what we used to have in our laboratory those days. So today we use cloud computing, and we speak about how the quantum computing helps us to compute. The technology is similar. Only thing is the speed in detection of the faults, has increased. So I will be talking about different maintenance types. Here you can see the products in the market, like motor checker, bearing checker, vibration transducer, ferrography. Ferrography means study of ferrous particles in the what is called that oil lubricant. So this was the ferrography helps us for the predictive maintenance systems. So let us go one by one. If you see in the next slide, I speak, there were some expensive machine fails, which we can see. All of you must have heard in 2010, there was a deep water horizon oil spill. Because of that oil spill, people could not, the oil leakage, so people could not use their ship for crossing the oceans and sea near US, and there was a lot of business loss. Same way, if you see the mobile Samsung Galaxy Note, that a small battery, the small battery defect, you can see here, small battery defect caused a fire, and $17 billion were damaged. Similarly, if you see, there was a blockage in the Suez Canal, and because of the ship, one of the largest containers in the world, the ship container, it blocked, and lot of the cost went to billions of dollars, revenue loss. Again, Apollo 13 mission, here the oxygen tank explosion, that caused, and everywhere the machine is giving trouble. And recently you must have seen the Ahmedabad, what is called that plane crash. We would have predicted if the oil sample was taken and it was analyzed, we could have predicted the failure of the engine well in advance. But we really feel bad that after the explosion, people took the oil sample and they are analyzing. Even today, they have not come out with the proper reason. What was the reason why the engine failed and all? So here, if you see the different types of maintenance systems, as I told, first one is preventive type, second one is predetermined type, third one is condition-based maintenance, fourth one is predictive, fifth one is corrective, sixth one is reactive. This reactive, what I was speaking, you can see here, I am showing with the cursor the example. In the reactive maintenance system, they collect Air India Boeing 787-8 crash in Ahmedabad. They take the oil sample and do the analysis, and they react that what engine can be, how the engine can be improved further. But if you come back to the preventive maintenance system here, you can see you do it. You try to prevent. The name itself says preventive, means you try to prevent it by regular and periodic checks in the running of the machine. So the benefit is, see, regularly we go take our two-wheeler or four-wheeler for preventive maintenance. We take it to every year for our car to get serviced. We see that whether oil is to be changed, bearing is to be changed, gear is how much worn out. All this is preventive maintenance system. Now, example I told about our car. So, if you come to predetermined, it is followed in a factory. Factory, they have a schedule. They make a schedule and they predetermined where they go on checking the health of the machine, and it is predetermined. So it is very easy to schedule and manage. And you can hire technicians instead of maintenance persons. You can what is called example for this are large machines are maintained in factories. Again, coming to condition based maintenance system, where the condition of the machine indicates the maintenance needs to be performed. So downtime is less. What is downtime? Downtime means when the machine is put off and maintenance is done on it. So in the next coming slides, we will see fixed cost and variable cost. So the fixed costs are like salaries, like the electricity, what we use for the room rent, all factory rent and all these things. Whereas variable cost, if you see the number of hours what we use on the machine, it varies. So based on the production times, production schedules, it varies. So if you see here, condition-based maintenance, so a greater productivity, equipment runs in peak performance for longer time. So here you got sensors for the pumps, motors, and other things. So you measure the vibrations and all. So we will go in deep with the equipment what we manufacture. Then comes predictive technology. The predictive technology, I told you earlier also in 1995, it was brought to India by a company called SPM Instruments India Private Limited, AMIEE, so where I used to work. So it had a connection with Predict Technologies, Cleveland, Ohio, and we used to take a oil sample just like the blood sample. We make a smear and the particles are identified and measured and the quantified with the purpose, with the machine analysis experience, and AI is used. Those days we used to use AI with respect to the servers what we had in our companies. Now it is global. We use the cloud computing and quantum computing for doing this predictive maintenance systems for process industries. Any industry where rotating equipment is there, we need predictive maintenance system. What is this corrective maintenance system then? It occurs to fix an issue or fault or failure or breakdown in an existing machine. So once we know there is a fault, suppose there is a lot of vibrations coming, we can solve the vibrations problem like we check for the foundations, we check for the bolts or nuts and bolts are proper or not. So we can correct the problem, root cause of the problem for the what is called that vibrations, and we can do the corrective maintenance. Reactive is after the incident has happened, like Ahmedabad case, we go and take the oil sample and find out, and we do the maintenance. We find out the cause for it, and we try to rectify it in future productions of the engines. So if you go to the next slide, I say here I told you there are fixed costs, there is variable cost. So fixed cost, as I told you, examples of the rent of the factory and salaries of the factory and all. Variable cost depends upon the raw material, how much we have purchased, how much raw material, how much time we have used the machine, how much manufactured product is how much product is manufactured and sold at what profit. This is all coming in. This all includes the variable cost. So when we do the maintenance, we have the fixed cost at its place, but the variable costs decrease, but profits also decrease. That is what I showed in this slide. So the next slide here, I speak about the predictive maintenance. Earlier, I told you, even in 1995, in the electronic industry, automotive industry, we use the sensors in the vehicle to collect the real-time data on various parameters of the engine, like how much wear and tear is there in the tires, how much wear and tear is in the engine, how is the lubrication condition, is the filter working, the filters which are there in the machine, whether they are working or not. One common thing I want to tell you all, my dear friends. So if you collect a oil sample before the filter and after the filter, you measure the wear particle concentration. We said WPC, wear particle concentration. So, and also measure the size of the wear particles which are there after the filter. Suppose the engine, the machine's specification says that the filter is of 10 micron filter, and you find a particle which is 20 microns or 50 microns or 70 microns after the filter. Very clearly we will come to know that the filter is not doing its job. The filter is damaged because we are able to find 50 microns and 70 microns particle even after the filter. That is one way. The other thing is wear particle concentration. It doesn't have any units, but we try to measure. There is a instrument which can measure the wear particle concentration. I'll be showing those things in the coming slides. So the wear particle concentration will tell us after the filter, that when we take the oil sample after the filter, it will tell that how much is the wear particle concentration. Before the filter also we take, then we can know the health of the filter in the machine. The other one is the wear particle concentration for a particular type of turbine or for a particular type of transformer or a motor or a generator or a alternator, whatever equipment it is. If you can take the wear particle concentration before the filter, we have a data that similar equipment in the world with similar environmental conditions and for similar manufacturing, what was the wear particle concentration for normal, for marginal wear and tear, for critical wear and tear. See, there are three classifications which we do: normal, marginal, critical. Normal means like traffic signal green. It shows green light in our equipment. When it is marginal wear particle concentration, it shows yellow color. That means it is going to get damaged anytime. When it comes to red, we have to be very, very alert, and it is very critical and very important. So normal, marginal, critical, these are the three classifications for the wear particle concentration value for each of the engine, each of the machine, what we have the database. So this database is built up over the years, more than 50 to 60 years. This database is available with a company called Predictive Technologies, Cleveland. So they have a tie-up with Predictive Technologies India Private Limited in Amirpet. So later on it is shifted to Kukatpalli now. So I used to work in that particular company as a machine analyst, and I used to measure and decide based on the quantification, wear particle concentration, that whether the machine is in green zone, yellow zone, or whether it is in what is called that red zone. So the other things are, I will take up the chat questions once the total presentation is over. So let me go ahead. I have not seen the chart, but anyway, okay, not much questions are there. Okay, the next thing what we see is here you can see in mechanical equipment, what are the different predictive maintenance systems. Just now I was speaking about oil analysis, then time domain reflectometry, vibration analysis, proximity probes, tribology monitoring, then performance trending. Now you see oil analysis, I was just now telling how much contamination is there, how much wear particles are there. There are equipment. I will show those equipments in the coming slides, that how the oil analysis is done, how the predictive maintenance systems are working. And coming to, and we can optimize the lubrication system. See, some of the equipment, they have 4,000 or 5,000 liters of tank capacity lubricants, and we all are aware of our bicycle. Even in bicycle, there is an axle which is connected to pedals. While we pedal the bicycle also, the axle broke many times. Even two-wheelers, four-wheelers, we have axles. So this is due to the vibrations which come. When we go into what is called a ditch on a road, there is shocks which are applied on these axles, and the machine fails. You can see that's why we use shock absorbers in the car or in the vehicles also. I'm taking the example of car and scooters because we all use them. So shock absorbers will absorb the shocks. So once the shocks are very high, vibration starts. When vibrations are very high, the equipment fails. So before the vibrations comes, at the level of shock pulses only, we can measure the shock pulses by using sensors. Those sensors are transducers, piezoelectric transducers, which we use in the industry. So after measuring those shock pulses, we can come to know the units are so many shocks per millimeter, so many shocks per micrometer. So that helps us to decide whether it is in red line, yellow line, or green line. Thereby, what happens is we can analyze the condition of the machine. So here, once we analyze the condition, vibrations, we can take the corrective action. So for proximity probes, we use these proximity probes to monitor the gap or distance between the rotating equipment, such as shafts and bearings. So I will talk about the predictive maintenance more as I proceed further into the details of the different wear and tear. See, the lubrication is generally used for two purposes. One purpose is to avoid the friction or decrease the friction between two materials which are touching each other. The other one is to remove the heat developed while the machine is working. So these are the two reasons for using the lubrication in any engine. So we take the engine sample and go for the predictive analysis. So the next slide, let us see some of the products in the market what I am involved in manufacturing. So you can see here, this is a very interesting thing. This is just like a thermometer, This is called motor checker. It can check the health of the transformer, health of the what is called alternator, any three-phase alternator, three-phase machine like generator, motor, alternator, or transformer. Here you can see, I am showing with the cursor, there are two sockets with resistance and inductance. And these two leads, from these we take two probes and connect to the three-phase machine. The three-phase machine may be motor or generator. We put off the power supply, 230 volts power supply. Otherwise, this motor checker gets burnt out. So we put off, and for hardly half a minute or 2 minutes, and measure the resistance and inductance values using this analog scale, 0 to 100. So very, very accurately we can measure the what is called that this values even up to 0.001 ohms, 0.001 ohms, and even 0.01 millihenries. So any three-phase machine should be perfectly balanced. That is, if it is in star mode or delta mode, whatever mode it is, Ry, what is the resistance? and YB, BR. We measure three values, and on all the three coils, the resistance and inductance should be more or less same. Then we say it is balanced. If it is not same, if there is a variation, then the coil is getting burnt, coil is getting degraded. That is what we conclude. Again, impedance is nothing but, this is nothing but impedance matching we are doing between RY, YB and BR, the three coils, three-phase coils. If the impedance is same, then we say the coils are very healthy. Now, this impedance is made up of resistance, inductance, and capacitance. Capacitance effect is very negligible. So in the industry, we measure this resistance and inductance using these two coils and probes. By pressing this red button and selecting the proper range, see, we proper range based on the equipment, we can measure, take the range, we can select the range and measure the values. So the impedance, if it is perfectly balanced, we say coils are good. The other one is from the coil to the body, from the coil to the body of the machine, that is generator or motor, we measure the impedance. That is called insulation resistance. We measure the resistance, that is called insulation resistance. We use these two sockets for that. 500 volts DC is generated by this instrument motor checker, and 500 volts is applied between the DC is applied between the each of the what is called coil and the body, and we measure. It comes in mega ohms. Can you see the blue scale which is there down? This blue scale is not uniform, and you can see it measures 20 mega ohms. It acts just like a mega. 20 mega ohms insulation resistance can be measured. More than that, it shows infinity. You can see here M and ohms, mega ohms. So this instrument, electric motor checker, is used in any process industry where there are motors, transformers, generators, alternators, transformer, and in the Navy, Indian Navy, we gave 200 such equipment. This is a thermometer for an engineer to measure the impedance and to know the faults in the machine. One more very, very good advantage of this motor checker is we can know the rotor cage bar cracks. In the rotor, the rotating part, rotor, there may be cracks sometimes develop. That crack can be identified by using this inductance value while we are measuring. The rotor is rotated physically by us 10 degree, 20 degree, 30 degree, and 360 degrees. Total 36 steps, 10 degree, 20 degree, and so on up to 360 degrees. And wherever, if there is a crack, there is a sudden shoot in the inductance value, the meter will shoot up values. Suddenly it will shoot. That means there is a crack in the rotor. Then we stop the checking and go into open the machine and try to change the rotor. So rotor defects, insulation defects, then insulation defects between the coils, then the health of the condition of the motor generator or transformer, any three-phase machine we can do with this machine, with this equipment. And the cost of this equipment is hardly 20,000 rupees. This thermometer of a doctor, like this motor checker for an engineer, acts as a thermometer and for an engineer, and we can buy it for 20,000 rupees. So this is a very good equipment. And apart from this, okay, somebody is asking for full screen show. I will show it, try to show full screen. Okay. Okay, I am not able to do it. Fine. I will share these PPTs to the concerned people. You can take and you can see this. And I will also give the website where you can get this. So this is for motors, electric motors, transformers, motors, generators, alternators and all. In the shipping industry, in the Navy also we supplied, all ships will be having this equipment. They use this equipment for finding the health of the motors and generators which are used in ships, big ships. So in Visakhapatnam, we have supplied 200 such 200 equipment, 200 motor checkers for the Indian Navy. Now, the next slide, which talks about, one second. Next slide is the bearing checker. So the bearing condition is found out by using these headphones and using this measure M value. Can you see here green, yellow and red? Green, yellow and red. There are colors here also on the display. You can see green, yellow and red. This will indicate, this will tell the condition of the shock pulses. Checking the shock pulses which come before the vibrations, it can give the readings and health of the equipment. So this particular model is very useful in the industry. They use, there are 3 models you can see here, different names are there, here another 3. So different models cost different things for different applications. We use this bearing checker. So let me go to the next slide. Here, this is another vibration tester. After the shock pulses have come up, vibrations come. That time you can use this. Here also you can see MCM, machine condition monitoring instruments, MCM instruments, Miapur. So this is the industry which I developed in the initial 2 years and then left it to the promoters. You can see the vibrations meter, WIP 33, it measures the vibrations, and based on the database, we can tell whether the machine is in good condition. That is, green condition is good, yellow is deteriorated, red is damaged. So the next slide will speak about the transducer. This is a transducer, the transducer means it is a stethoscope for the doctor. As stethoscope is there, this transducer is going to pick up the signals, electrical signals of the non-electrical is converted to electrical signals by this transducer, and the electrical signals are fed to the instruments what I have shown, and thereby it can predict. So now let me go into the correct subject. This is the ferrography technique, Predict Technologies, Cleveland, USA, who have brought the equipment in 1995 to Ameerpet in Hyderabad. And this was the first company. Predict Technologies India Private Limited is also there from those days. So here you can see, this is the ferroscope. This is the ferroscope, what I told, which is used to measure. It is 100x, 500x and 1000x. This eyepiece is having values. We make the blood slide, just like the blood slide is made on a glass slide, you put the blood and take the sample of the blood and try to find out the ferrous particles. That is, whether it is low alloy steel, medium alloy steel, or case hardened steel. See, case hardened steel will look something like, case hardened steel will look something like this, purple color, Can you see here this purple color? This is case hardened steel. So this particle has come from the gearbox. If you see this yellow color, they have come from bearings. This is a medium alloy steel. Can you see this ferrous particle cutting? This is called cutting wear. You can see this is something like the, what is that called? Lathe machine turnings which have come out. So the gear wear, this is the gear wear. This is the bearing wear. This is the case hardened steel coming out from gear. And if you see this type of blue color, sky blue color, it is from the shaft of the machine. Shaft rotates, shaft rotates. The rotating part has worn out. So I was one of the analysts like this who was using this ferrogram under these ferrous particles, and I used to measure the size of the microns. Suppose wear particle, size of the wear particle. You can see here, this is going to measure the wear particle concentration. This instrument measures WPC, wear particle concentration. It tells the what type of wear it is, severity, how much it is, which component it has come out from, what is the cause of this machine wear. whether it is from gears, bearings, or the shaft. And we can quantify it by using wear particle concentration machine. This is the WPC machine. This is the ferrogram, what we are making. Ferrogram means it is a slide, just like our blood smear. They put it below the ferroscope and they measure. That is how they do that. And finally, we write a report in the next slide. This is a report. This is a report where you can see red means critical. If it is yellow, then it is marginal. If it is green, it is what is called okay. It is normal, marginal, critical. These are the three ratings we give overall machine, and we give the recommendation. We also give the results. How much wear particle concentration is there, and as I told, the company name is Predictive Technologies, Cleveland, USA. And in India, by chance, we are in Hyderabad, and Hyderabad is having this company called Predictive Technologies. We give this report. This is the first part of the report where we give the recommendations. This is a sample ID, just like blood sample ID also we give. Name of the component is bearing, lubricant, how much it is, all details we give here, which date it is, sample is collected, when the report was made, what is the recommendation. Recommendation means changing the oil may be a recommendation, changing the filter may be a recommendation, or the recommendation may be that another 6 months this particular machine may not work. And we discuss the results, all these results. All this is done by using AI. In my times, we used to have the server in our company, but now cloud computing, quantum computing has come up. That is the only difference. Otherwise, the same technique is used. You can see the results here. What are the different types of wear particles we are seeing? Cutting wear particle, severe sliding wear particle. Sliding means one material sliding over the other. Then normal rubbing, normally it has rubbed, normal rubbing where 0 to 10 scale, 0 to 10 scale we give the rating. See, if anybody gives you a particular quantity of, suppose, peanuts, you just take it in your hand and measure. You can say whether it is 100 grams, whether it is 150 grams or 200 grams. But no, a 200 grams quantity, nobody will say it is 1 kg, right? Same way, based on the memory what we have, based on the intelligence what we have, we can measure, we can quantify the wear and tear of the machine in the oil which is there by making these slides. And here you can see the trend also is given, percentage of large wear particles we have given the y-axis, x-axis the different dates and trending. This trend will tell us when the machine may fail. So ferrogram, this ferroscope, making a ferrogram and analyzing the ferrogram. These are the three stages for doing this ferrography technique. For finding out the type of the wear particle in the oil, severity of oil problem, severity of the problem, then what are the components they are getting damaged. I want to share one thing. I was in L&T cement plant in Awarpur Cement Works, where there is a bearing which is size of 10 by 10 room. 10 by 10 room, whatever size is there, 10 feet into 10 feet room, that size bearing, it costs 4 crores. From Germany, they have to import. Suppose they are using this ferrography and technology, ferrous technology, ferrography technology, they can get the bearing just before 2-3 months before, and they can keep the stock. If they keep the stock for 1 year, 4 crores interest, you can see how much money is lost there. So now time is running short. So these are the various types of technologies, like preventive technology I told, time-based technology I told, predictive technology I told in detail. The equipments what we are using, you can see this is the different equipments what we are using. In the industry, we use these equipment for measuring vibrations and shock pulses. So based on the color, color of the particle, we can tell that from where it has come. So this ferrogram is heated for 70 degrees temperature, and then we can get these colors based because of the structure of that particular components. This is from bearing. This is from the bearing. This is from the gears, and these particles are from the gears, cutting wear. These are the normal rubbing wear. So different types of wear particles I have discussed. Now, any questions you can question me, or the organizers can take these slides, and they can put questions. They can write to me, and organizers can also give these slides to the participants. Any questions you can ask me, please. Make it fast. Anybody? Chat box, let me see if anything is there. And I suppose the time was very short. Anyway, organizers, please come into picture. I have finished my lecture.
Thank you so much, sir.
Yes. So I will share the slides if required. I will also give the website connections. So any interested participant can see the website and they can contact me also. And I will be available. And my details, like the organizers will be having my details about the phone number and mail IDs. I am a professor in CBIT. Earlier, I worked for Predict Technologies, and also I have established an industry. While working in CBIT, I have given my consultation to the company, and it is doing good. NCM Instruments India Limited. It is in Miapur, Hyderabad. Okay. Fine. Thank you. Yes, madam.
Thank you, sir. Thank you so much. It's my
Yes.
honor to introduce our dynamic speaker, Dr. Anubhav Kumar Pandey, currently serving as Assistant Professor in the Department of Electrical and Electronics Engineering at Dayananda Sahar College of Engineering, Karnataka. Dr. Pandey is a recipient of DST Inspire Fellowship and completed his PhD at Manipal Institute of Technology. With a strong background in engineering technology, he has published numerous Q1 Q2 journal papers, presented at prestigious international conferences, and serves as a trusted reviewer for top elsewhere and IOP journals. His research spans across virtual power plants, electrical vehicles, smart grids, power markets, and sustainable energy systems. He is also a technical committee member and has reviewed over 400 conference papers. We are delighted to have you join us, sir. A warm welcome.
Thank you very much, madam, for my brief introduction. And yeah, I guess I'll share my slides now.
Yes, please, you can share. I stopped sharing.
Okay, right. Yeah, so may I kindly request to please confirm that whether I am audible and my slides are visible and it is also floating.
Yes,
Yes,
sir.
it is audible, visible. Please go ahead.
Okay, thank you so much. Thank you. Yeah, so a very good afternoon to all the members and participants and esteemed members who have presented in this very aspiring FDP, which is application of artificial intelligence and machine learning in electrical engineering. So I guess even I was also attending in past 2 days. Even I have also attended few of the FDPs, and because of a very tight schedule, I cannot attend all the sessions which has been discussed by experts. So whatever I have attended so far, I think I have heard enough of AI. What is AI? What is ML? What is deep learning? So all this, very basic classification and all its definitions, its meaning, its
Sorry to interrupt
what
you,
this
sir.
terminology means.
Hello, sir.
Yeah, yes.
Sorry to interrupt. Yeah. So please switch on to the slide mode.
Okay, sure. Yes, whether it is in slide mode now,
Yeah, it's okay.
it is right.
Yes, now it's
I
okay.
think
So please
yeah,
continue.
it's yeah, okay. So I will not stress much on the specific definitions of AI and ML and deep learning. I'll just discuss that how these advanced technologies are paving the shape of our life, and how specifically in power systems it can be utilized to detect the faults, which are one of the major aspect which has to be tackled very carefully. And also, as we are technologically advancing in every other day, in every other aspect. So as far as power systems are concerned, we have to have this AI based leveraging technology which can give us some additional kind of hands on setup, so that the accuracy can be improved, the time response can be improved, and along with that, the precise detection of fault can be achieved. So in line with this slide background, I will discuss that what are the contents which I am going to cover in the time slot which I have been allotted. So we'll start with the very basic introduction. We'll also discuss some types of faults, and which is followed by the comparison in approaches, which is specifically in line with our conventional approaches, followed by the advanced new age AI based technologies, and how we can detect the faults by employing some AI methods, followed by its actual real world applications, and which specifically means how we can upsurge the technology from lab to market aspect. So that also we will discuss slightly. Along with that, what are the tools and platforms we can use, followed by its specific accuracy and contribution based on some different technologies. Along with that, we'll also I'll try to throw some light on the comparative analysis, and finally the advantages and some of the cons which are associated with the artificial intelligence method. And this will be the presentation will be expected to be concluded by the research trends which are going on in the field of AI based fault detection in power systems. So with this, we'll start with the presentation. And so we can say that from past 3 to 4 decades, the power generation, the transmission and distribution is somewhat isolated, and it has been centralized in centralized structure. But from last 5 to 10 years, if we analyze, especially from past 1 decade, there is a rise in this DERs, which we abbreviate as distributed energy resources based power generation. And the power generation is coming from very disparate locations. So we have solar, we have wind. In solar also, we have rooftop solar, we have residential based setup. So all this power are coming. Along with that, solar and wind are considered as two of the most prominent renewable energy resources. But in line with solar and wind, there are other renewables also, like small hydro, which has been recently categorized as renewable technologies only. And if we go by the large hydro, it is designated as a conventional power generation. But small hydro can be clearly considered as a renewable based power sources. So that is also coming into the picture. Then fuel cell technologies are also there. So cumulatively, if we see, there are a lot of DERs, distributed energy resources, which are coming into the energy mix. And as we are aspiring to involve more and more power generation from these renewable energy resources, the important thing which has to be considered is when it is integrated with the utility grid, then the whole dynamic of power system is going to be not partially, but almost completely, it has to be changed. So for that, we require the infrastructure upgradation, because completely changing the dynamics of power system is not possible, but upgradation is possible, which can only be happened in phases. In short phases it can happen. So considering this variable nature of renewables, the problem is we have the prediction is the most important thing. It has to be predicted accurately. Once the prediction is accurate, we can have a schedule and dispatch scenarios, which is carried out generally by the state load dispatch centers and regional load dispatch centers. So these people are responsible to carry out those kind of scheduling and dispatch. But for that, prediction is very much required. So in that way, also AI is going to play a major role. Now, since we have talked something regarding DERs, this is followed by the bidirectional power flow. So bidirectional power flow is also one thing which is happening now because of this variable nature of DERs. And there how the smart grid is evolving, the whole infrastructure is evolving. Also, if we see our conventional approaches, which I'm going to discuss a bit, is comparatively slow and rigid. So the inclusion of these variable loads to make our power system modern is in transition phase, and due to these rapid advancement, we have to involve these non-conventional sources in the energy mix. And this monitoring and control of these variable renewable energy resources are where we have to merge, we have to integrate it as a single entity, and then only we can interface it with the utility grid. So this is the very brief motivation for this particular topic. And as we are succeeding to our next slides, we can discuss that this will also going to create a lot of problem in terms of the fault issues. So basically, the AI are transforming our power system protection. When we include this kind of technology, this kind of new age artificial intelligence technology, it is going to be upgrade itself from reactive to proactive by accurately detecting, properly classifying, and predicting the faults with speed and precision. So these two aspects are going to play a major role whenever we are talking about AI-based fault detection in power systems. So the importance of this strong intrusion detection systems and advanced cybersecurity measures, because see, these days people are talking about microgrids, and there is one more very important concept which is going to evolve our power sector completely. I think many of you have heard of it because that is one thing which I wanted to emphasize, because in that research area only I'm working from last 5 to 6 years, couple of years. So that is virtual power plants. So it is actually a upgraded version of microgrid, and the majority of difference between the virtual power plant and microgrid is it is always grid connected. So microgrid, we are having one option that we can island our system. Islanding is possible. That phenomena is possible. But virtual power plant is completely grid connected. It is always connected to the grid. If because of some reason the grid is down for particular time and it cannot fulfill the power requirement, then we can have some or the other kind of a storage system, storage based, battery based energy storage system, or some other kind of energy storage system, so that the power can be fulfilled. So why I am emphasizing on that is these microgrids and virtual power plant are very very technologically advanced thing, but cyber security measures and cyber security issue is one of the most important thing which has to be tackled if we are discussing any of those kind of advanced technologies. Then only it can be it can be inclusive in all aspects. So to have some reliable grid operation and to have the prevention of more significant interruptions, that those cyber security measures are also needed to be taken care of. So there are some of the traditional approaches, but as the machine learning and deep learning concepts are evolving day by day, it is expected to prefer and to tackle the issues in this dynamic smart grid environment. So also considering this particular cyber resilience for to ensure the impeccable operation of AI based techniques, are required to advance the smart grid network. So we'll discuss something about faults. I think most of you are already aware, but since this is the most important part of our topic, we will emphasize a bit on the types of faults. So as we discussed, that power systems are very complex in nature, and its functioning becomes quite vulnerable when it comes to these kind of faults. So these are some symmetrical faults in which line to line faults are there, three-phase line to ground fault are there. Those are considered as symmetrical faults. These are followed by the unsymmetrical faults in which line to ground are there, line to line is there, double line to ground faults are there. And if you see in unsymmetrical fault, the majority of the faults are categorized as line to ground faults based on their occurrence. So it is roughly around 70%. So these are something about symmetrical and unsymmetrical fault. This for transformer are concerned. So the other aspects of faults will include open circuit fault, short circuit fault, and incipient fault. So these incipient faults are immediately not that much intensive in nature, but if these faults are not taken care properly, so over time it has the tendency to become or to transform itself into a major fault, which will lead to a major damage to the particular system or the particular equipment. So since incipient fault will not do immediate damage, but the extent of its intensity can increase if it is not taken care of within the time limit. So these are also important. So we'll discuss something about the conventional method, that how we are so far carrying out the fault detection method based on our traditional system. So it is impedance based method in which we are going to measure the impedance of transmission line. But as far as those faults are concerned, but the problem is, it is problem which has been encountered is it is quite time consuming. And in power system, the things has to be taken care of, not minutes also, I must say. It has to be within seconds or milliseconds. So then only power can be restored and can be the power power supply continuity can be carried out. So this is one method. Another method was fundamental frequency component based method and traveling wave method. So this is also one method, but in this particular method, more human involvement is required. Manual intervention is also required in this particular method. Along with these two, there are digital relay based algorithms, based advanced algorithms. But as if we compare with the previous two, this the detection capability is quite improved in case of this third one, digital relay based algorithm. So these are the very basic ways of how we are detecting the fault through traditional approaches. So we'll see that how AI is going to transform it, and how what exactly the role of AI is playing in this particular scenario. So as we discussed that it is power system, this whole structure is very complex, and it is particularly vulnerable when it comes to the mentioned faults. So usually AI based processing will start collecting the data, because these systems are data hungry, as we know. The the more data we feed to it, the more decision making the particular system can carry out, and therefore these systems are also called as data hungry system. So if you give it a less amount of data, it will again give you the result. It is not the point whether it is going to give you the result or not, but the precision, the accuracy will be questionable. So that is why we have to increase the amount of data. The more data we can give, the better result we can expect in return. So the first process is the first step is the pre-processing, which is followed by the acquisition of this data. Then the most important thing is to detect the type and classify the specific fault. So if it is line to ground, the detection must be line to ground only. So the accuracy is expected to be more than 99%, because in my opinion, there is no such thing as 100%. Even we can be accurate like 99.99%, but 100% accuracy is again debatable. Not saying that it is not possible, but that is something which needs further discussion. So detection should be 99.9% correct and followed by its classification. So we can determine that which type of fault has occurred. And finally, once these two steps are, these are the broad classifications of AI-based processing. Once this is completed, then only we can see that how we can identify the location of fault. Once the fault is located at a particular place, then only it has to be rectified, if not mitigated completely. And this is followed by the restoration of power supply. So these are some three broad, scope of AI-based processing. So we will move on to next slide, in which I'll be going to discuss the AI methods for fault detection. So first one is, we'll discuss about fuzzy logic. So fuzzy logic is usually implemented in detection of fault, in which there is a reduction in uncertainty while measuring the fault. So there are uncertain natures of various resources which I have already discussed. But when it comes to the fault, that particular thing has to be taken care of. So fuzzy logic, based on that, we can have this particular freedom with us. This is followed by the machine learning approaches, in which mostly you might have heard of this decision tree method. It is a broad classification, and based on that only the random forest technology can be applied. It is a sophisticated optimization and an algorithm method. So based on that, we can determine the fault. Along with these, there is another which is called SVM. The abbreviation is support vector machine. So these two are broadly classified under the category of machine learning methods. Now this is followed by deep learning. So these are relatively advanced method as compared to machine learning. So in the subsequent slide, I'm going to discuss one graph in which the accuracy percentage is also shown. So we will discuss in that particular slide. So coming to the deep learning, there is waveform-based method of fault classification, in which CNN is there. So I think we are aware of CNN. It is convolution neural network. It is the advanced function of ANN, artificial neural network. And this is followed by the LSTM, long short-term memory-based method, which is generally sequential-based method of any fault prediction. Apart from these three, we can have some hybrid kind of technologies, which is the graph which I have mentioned, which we'll discuss a bit. So that particular thing also, when we combine these methods, when we combine this ML or DL method, or if we combine the combined attributes, we can actually leverage its full capability. And therefore, the hybrid methods can be a combination of this, either machine logic or machine learning or fuzzy logic. And this is followed by the additional expert rules, in which the precision will be enhanced somehow to a greater extent. So these are some of the AI-based techniques. And now we'll discuss about the tools which are required, or platform which are required to, which are powered by the AI techniques. So these are machine learning, as I have discussed. From the conception point of view, it is support vector machine, it is random forest, it is KNN is also there, which is K nearest neighbor. And in deep learning, there is advanced version of machine learning, which we have already slightly discussed. It is convolution neural network and radial basis neural network. This is followed by the there is one more term which I have mentioned, FL and RL. So the abbreviation of this is federated learning and reinforced learning. So these two are more suitable whenever we are having some imprecise data, or when the data precision is comparatively less, and also it can take care of the uncertain nature of these faults. So these are some of the conception based requirement for the tools and platform. Now, if we see in broad classification, these are presently the percentage share of AI-based techniques, in which, if you see this pie chart, the majority has been carried out. It is roughly 34 to 35%. The majority will be carried out by machine learning based method, which is followed by another 31%. These all are in percentage share only, which is deep learning. This is followed by the unsupervised learning, which is 15%, and hybrid techniques, in which there must be a combination of either of these two technologies. So it is currently, the share is nearly about 20%. So these are the shares of these techniques. Now, if we go by the approach, or specific approach and accuracy in the fault detection, We can see in this particular graph that if we go by the percentage accuracy, there is a scale of 0 to 100%, and conventional method can almost detect the fault in 80 to 85%. This is the right block. I want you to just pay attention. The right block, the light blue block, conventional based method, which we have discussed. So it is going to give the accuracy nearly 80 to 85%, but I think not more than that. Coming to the machine learning process, it can give the efficiency of almost 87 to 90% machine learning. Deep learning is an extended form of particular AI technology which can give almost 92 to 95%. But hybrid technique, which I have been mentioning, the combination of the amalgamation of these technologies can give with an accuracy of almost more than 95%. So what I have referred is it is showing some 95 to 97%. So I think it is pretty decent. And even if we see from the conventional approach, it was roughly 85%. So from 85, we have reached in terms of accuracy almost 97%, not more than that. And it is expected that in the coming time, this remaining percentage will also going to get improved. So yeah, so coming to the comparative analysis in which AI detection versus conventional approach has been drafted, and there are few parameters which I have mentioned in this slide. So if we see the type of maintenance, the conventional method I have mentioned, as I have mentioned, it is more and more with respect to the human intervention or manual intervention. So that is particularly required. Round the clock supervision is required, and lot of human intervention is required in that method. But AI based detection deals in the self-learning approach. So automatically, as the grid condition is keeps on changing, it is not constant, because mostly if we see the conventional approach of power generation, we know that how much power exactly we are, or almost approximately we know that how much we are generating, what will be our requirement, how much we have to transmit from which point to which point we know. So we can maintain the inertia of the system. That is one thing which I want to mention here. But as more and more renewables are coming into the picture, the inertia of system will get disturbed. And to maintain that, we have to make such system, such capable kind of holistic system, which can continuously, adapt itself to the varying or changing grid conditions. So that is why it has been mentioned that self-learning, it can, based on the data whichever we feed, whichever data we give to the system, it has to be auto-tuned based on the changing grid conditions. So that is one very important thing which I wanted to mention in this presentation. Now we'll go to the next parameter, which is its ability, or we can say it as a capability. So conventional method, the ability is of course very limited. It is not beyond a certain extent we cannot go. But as AI based detection or self-learning in nature, the ability of it is very high. It is extremely high, and it is dynamic also. This is followed by the accuracy, which we have just discussed. I think I have just I have mentioned greater than 95% in the right column and 80 to 85% in AI based detection. So this is one thing which I have just interchanged it. So just please, I beg your pardon for this. So we can say that accuracy is greater than 95% in AI-based detection, reaching to almost 97%, and in conventional method, it is 80 to 85%. So this is in terms of accuracy. Now coming to the responsiveness. So the system has to respond accurately. So as I mentioned, in power systems, we cannot, wait for even for a minute whenever there is a particular detection or identification or isolation of faults are needed. We cannot rely. Immediately it has to detect, it has to identify, it has to classify, and it has to restore it accordingly. So even in conventional method, it will give in nearly some few seconds it will require, but it will give in some seconds. But again, that time limit will be fixed. But as far as this AI-based detection is concerned, it is less than a second. So we can say that within a millisecond, it is going to detect, it is going to classify, and it is going to reveal the exact nature of fault. So that is why flexibility aspect is something which we can achieve in AI-based detection as far as the responsiveness is concerned. Now, this is followed by the computation ability. So, of course, computation ability in conventional method is relatively low, but in AI-based detection, it is not decent, it is actually excellent. So, whenever, as I have mentioned, I've been working with a few of the optimization techniques to, solve the particular virtual power plant problem, VPP problem. So, whenever I have used any optimization technique, it is almost, quintessential. It is required to mention that what is the computation time that particular optimization technique has consumed. So based on that, whenever we do any comparative analysis, since we are comparing conventional and AI-based detection, I thought I'll spend some few seconds on it. Whenever we are comparing any particular technique, in this case, we are comparing conventional-based approach and AI-based detection. Whenever we are comparing anything, that particular computation complexity is very much required to mention. So based on that only, it can be determined that how effective your particular selected technique or method is. Based on that only, we can we can justify that why we have selected that particular optimization case, optimization technique in that case. So computation ability is also excellent in AI-based detection as compared to conventional. And finally, the complexities which I have been mentioning, it is also limited in conventional method as it struggles to adapt to the changing grid conditions. And in terms of AI-based detection, it is self-adaptive, it is self-learning, and also one very important term which I want to mention is it is self-healing. It is also self-healing in nature. It can heal by itself. Once the fault is detected, it can heal it by itself. So that is why it has been mentioned as self-adapted to complex scenarios. So again, we will talk about this, that how a conventional are very much outdated and how new age AI based technologies are coming into the picture. So this I think already we have discussed. Delayed response, limited accuracy, and also it requires a regular tuning. If you don't tune the system, the conventional approaches cannot help you for a long time. But this new age AI method is something in which we can get real time response. So scheduling and dispatch is, power scheduling and power dispatch is something which we'll usually consider on a day ahead basis. So day ahead basis, as I hope that you all are aware that we are carrying out for a 24-hour time scale. That is why it is called as day ahead. We are already having the prediction of the power requirement on a day ahead basis. So why I am saying this is, as that particular scheduling approach is effective, but it is again, we have to extrapolate its time scale so that we can have some glimpse of real time response. So if I talk about the day ahead dispatch scheduling, it is fine, it is effective. But if we can transform it into a hourly based scheduling in which every 30 minutes instead of 1 hour, every 30 minutes it is going to update itself. Likewise, what if we can divide it into a 15-minute block? So if you see in 1 hour, it is going to give you the demand for almost 4 blocks. So 4 blocks in 1 hour will be equal to roughly 96, right? So 24 4s are 96. So some 96 blocks. So you know how this real-time thing can be comparatively more effective as compared to the day-ahead scheduling. This is followed by another actual real-time scheduling in which we can consider, we can even extrapolate for 5-minute time response. So every 5 minutes, the system is going to update itself and it is going to give you the latest requirement, what is required. So that is why all those things we have to consider, and at the same time we have to see that that the system should not burden itself in terms of the complexity. That is why I am restricting myself to 5 minutes. Even we can go for 1 minute time scale also, even we can go for some seconds also. But then just imagine how much computational burden we are imposing on the system. So 15 minute and 5 minute is something which the researchers across the world have agreed upon, and they came with that particular regulation that yes, a day ahead hourly based scheduling and real time scheduling based on 5 minute time scale can be retained without burdening the system with additional computation complexity. So that is something with related to real time response. Now also we can have some consolidated information in which the noises and uncertainty can be reduced relatively as compared to the conventional approaches, and this is followed by the auto adoption of new age based AI based technologies. Uh, so yeah, I think on my screen there is some red markings I am seeing. Madam, can you just tell me that what is the that something happened on the screen? Madam, are you there? Hello,
Yes, sir, I'm here.
Madam, can you see the screen? I think it is completely. It is red marked. Uh,
1 minute, sir.
yeah. Yeah, thank you. Now it is removed. So this is one image which I have taken in the slide, which is the general architecture for intrusion detection. It is just for the sake of discussion. That is why I have also given the source. It is published in Cluster Computing Springer Nature paper, recently published paper. I found some relevance with respect to this particular topic. So intrusion detection system, which I have mentioned in the very first slide. So these new age devices, which are IoT connected devices, in which smart meters are there, advanced sensor are there, embedded microcontrol based sensors are also there. So all of these are interconnected, and when these devices are interconnected, the data collection aspect will be comparatively more flawless, more fluent. And then these data are collected, which is followed by the pre-processing, which I have discussed in the previous slide. There is another block in which has been mentioned in this particular figure, which you can see as ensemble model. So ensemble model is something which is, combination of multiple decision. So if we are going by a particular opinion, if you are going by an individual opinion or individual decision, it cannot be more consolidated. But when we have a certain number of opinions, when we have a certain individual decisions, and when we can combine it together, we can have the feel of or glimpse of this particular ensemble modeling. So this is particularly very much relevant in terms of the intrusion detection. And once that particular detection is identified and classified, it is going to alert the control center, particular control center, which is followed by its necessary mitigation, whichever step the control system or the independent system operator, ISO, that is one term which is very important, which we'll use. That particular person or the command center is responsible to mitigate that particular fault once that particular fault has been alerted. So coming to the real world application, there are fault prediction in transmission networks. There are dedicated smart grid based fault monitoring, and also the protection of generator and transformers are there. And there is also some renewable energy resources based grid integration. Broadly, we will call it at DERMS, DERMS. That is, it is expanded at distributed energy resource and management systems. So that is also particularly very much relevant in terms of the practical applications. And also coming to the potential, the AI model can detect the fault particularly relatively early The early detection is possible by this advanced AI model. It can also bring some preciseness in the classification of fault, and as already discussed, it can give you the rapid detection in terms of, as compared to the conventional approaches. And it has the ability to adapt to the changing grid condition, and this is followed by its enhanced accuracy by analyzing the grid changing condition. It can always adapt continuously towards its grid changing condition. So also there are certain advantages in which we can have some high accuracy due to real-time processing, which I have discussed comprehensively, how real-time processing can give us comparatively more decent results. The downtime is also very minimum. It has the enhanced capability of restoration, also called as self-healing, and also it can adapt to the changing grid condition. So there are still certain barriers in AI detection. So the most important one, which is mentioned in this particular figure, is data scarcity. So data scarcity is the situation in which we require a lot of data for particular system to make a informed and precise decision. But due to the scarcity of data, it is relatively difficult to reach to a particular solution. So data scarcity, because I'll give one example, that whenever you want any data related to solar, particularly I'm emphasizing on solar, and also I will include wind. Whenever you want any data related to solar and wind, I think you will get that data online from a particular research paper. You can get from secondary literature, or you can get it from a particular company or website. It is available. Even you need not log in also with your particular user ID or registration ID. No, it is not required. You can download the data based on seasonal variation. Also, you can download data throughout the year. It is possible. But when it comes to a certain kind of data, like I'll mention one more source which I have mentioned earlier also, fuel cell, or a combined heat and power generation, CHP, you will not get that data. It is, the chances are very rare, because that is something which I personally have struggled during my research. You will not get the data. Even if you scroll some of the relevant research papers, they'll give some reference, but when you go to that particular site or a website or particular DOI link, that data you will not get, or at least it is going to ask you some money. It is going to ask you have to pay, then only you can access data, that too with limitation. You can only do it with your analysis. You cannot make it public also. So those things are particularly classified as data scarcity. So this is one of the most important barrier in AI detection. This is followed by cyber security protection, which I have touched slightly in my very initial slides, and this is followed by the true real time. So since we have already reached the 5-minute scheduling and dispatch window that we have reached, but still the true essence of real time is still debatable, because there is always possibility of further scope of improvements. That is also one issue, and this is followed by the throughout modernization which is required across grid setup. So these are some of the barriers in AI based fault detection. And if we talk about that, what lies ahead for artificial intelligence? So this is one thing, FL, which I have mentioned in the previous slide, federated learning, which is particularly suitable for distributed power system. As I have discussed, that there is a centralized structure for conventional approach, and there is a decentralized structure, which now rapidly we are moving toward that particular structure of power system. So it is decentralized, it is distributed power system, because power, even small scale power, is also coming grid. So federated learning is particularly suitable for this decentralized and distributed power systems. This is followed by the NIoTs, which I have mentioned. It is nature-inspired optimization techniques. So there are more than 300 to 400 optimization techniques which are currently available, including its conventional, the original version, the modified version, and various kind of advanced version of those particular techniques. So these optimization technique is also going to play a huge role in in this fault detection. This is followed by the DTs and decision trees, which we have already discussed a bit, and this is followed by the most important thing, interpretability of any particular fault. So these are the research, I think, past 5 o'clock, but I'll just take 1 more minute or 2 minutes, madam, if it is possible, and I'll just quickly wrap up. So this is the research trends, AI-based power system, in which the very important thing, congestion management, how we can rectify the congestion management, because now we are aware that even apart from renewables, electric vehicles are also coming into the picture, and more EV adoption is encouraged by the government. Recently, one news I was reading day before yesterday, before while preparing this presentation, I came across that even people are sending their diesel powered Mercedes, which might have costed them more than 80 lakhs. They have somehow scrapping it in some 5 or 6 lakh rupees, because of the new EV policy which has recently been adopted in Delhi. So this is something which is going to happen, and in the coming year, as the government of India is only initiating these initiatives, this FAME 2 approach, faster adoption and manufacturing of electric vehicle, more and more EVs are going to inculcate in the picture. And when it happens, the problem will be congestion management, because everyone want to charge their electric vehicle whenever they will reach to their home, from to their respective homes after completion of their regular routine work. So how congestion management we are going to manage? So for that, a very robust network of charging infrastructure is required, which is also getting approved by various private players. So all these things are coming into the picture. So this congestion management is something which need to be taken care of. This is followed by the grid ancillary services in which voltage regulation, frequency stability needs to be taken care of. Stability analysis and hybrid generation and transmission and expansion planning is also very much active in the research trend. This is followed by the automation of power system, like how we can we can have a true modern power system in which the automatic self-healing or restoration can happen once which has very specific meaning. So it has to be, the system has to be self-resilient and robust in nature. This is followed by the last one, which is electricity market exploration, at how we can participate in wholesale market, in which again the virtual power plant technology VPP is going to play a huge role. Because of that particular advancement only, even if you if you search for IEX website, it is Indian Energy Exchange website. It is our Government of India powered initiative only. You can get all those data, the intraday market data. It is not interday anymore. It is intraday. So inter means it is the difference between another 1 or 2 span of days. But intraday, we are bidding in the wholesale market in that particular economic dispatch block. So that is also very much trending. Those who are who wants to have some new essence or novelty in this kind of particular research, I think you can just go ahead with this. There is huge scope with it. And for this is followed by the trading and bidding strategies. These are some research trends which I want to discuss as far as AI are concerned. And finally, there is huge scope, ample of scope which lies ahead to explore this artificial intelligence based advancement in power system applications to make it a holistic and self resilient and sustainable modern power system. So with this, I will wrap up my presentation, and I think I am open for any questions. Thank you. Thank you very much for listening to me patiently. Madam, am I audible, madam?
Yes, sir, you're audible.
Yeah.
Okay, if there is no question. As we come to the close of today's technical sessions, I take this opportunity to extend our heartfelt thanks to all three of our distinguished speakers, Dr. G. Suresh Babu for his insightful talk on condition monitoring and fault diagnosis, Dr. P. Narahari Sastry for shedding light on predictive maintenance of machines, Dr. Anubhav Kumar Pandey for his forward-thinking presentation on AI-based fault detection in power systems. Thank you for your valuable insights, which have truly enriched our understanding. On behalf of the organizing team and participants, we thank your contribution and look forward to more such inspiring sessions. I would like to extend my gratitude to AMIEE Association for this opportunity and to host the session today. Thank you once again.
Yeah, thanks, madam. So yeah, I will also leave the presentation. Thank you. Thank you for inviting. Thank you.
Thank you, sir.